Okay, so this is the second part of what we did tonight in our meeting. This is a quick review of topic 22. Um, this is a synopsis of topic 22, which is where we multiplied radicals. So, for example, if you look at number 1, you have the square root of 7y to the 11th times the square root of 28 y to the 15th. And so when you multiply two radicals together, remember the product rule says I can write this as one radical instead of two if the indices are the same, and they are. This is square root, square root. Okay? So I can write this as the square root of, and then you just, now use your calculator if you need to, 7 times 28. So 7 times 28 is 196. And then I have y to the 11th times y to the 15th. So remember in a previous course, when you learned the product rule for exponents, when you multiply like bases, you add exponents. So it'll be 11 plus 15 is 26. That's y to the 26. So this becomes the square root of 196, y to the 26. Now, the next thing you got to do is simplify this. So when you see multiply, multiply just don't mean to do this. You got to simplify as much as possible also. So let's think about rewriting this as a product again. So that becomes the square root of 196 times the square root of y to the 26. Now let's think about the square root of 196. So use your calculator to figure out, well, is there a perfect square besides 1 that goes into 196? So let's try 4. So 196 divided by 4 equals 49. So what I want you to notice, this is a perfect square and this is a perfect square. So that means 196 is a perfect square. So if you think about, well, so the square root of 4 is 2, and the square root of 49 is 7. 2 times 7 is 14. All right. So if I take the square root of 196, square root, use your calculator, 196, notice I get 14. So that's just 14 right here. And then this is easy to simplify. You always remember you can simplify a radical that has a variable ratio and exponent whenever the exponent is greater than or equal to the index. So 26 is greater than or equal to 2. So I can simplify this. Now this is an easy one because 26 is divisible by 2. So 26 divided by 2 is 13, so it becomes y to the 13th. It makes sense because y to the 13th times itself, 13 plus 13 is 26. And so there's the answer there. So you simplified it. Okay, number 2, we have the square root of 2 times the square root of 50 minus 4. So in terms of a review, remember in previous courses where you had 2 times x plus 5. So when you multiply this, one of the approaches you took was to use the distributive property when you had a monomial times a binomial. So this becomes 2 times x is 2x, and then 2 times 5 is 10. And so that's what you use there. So you use that same idea here because you have a monomial times a binomial. And so you can use a distributive property. Okay, so I'm going to go ahead and write out the step though. So you're going to say the square root of 2 times the square root of 50, because that's what that is, minus, and then the square root of 2 times 4, so it'll be 4 square root of 2. And so I know, just like I did this right here, that when the indices are the same, I can multiply the radicands together. So 2 times 50 is 100, so I get the square root of 100 minus 4 square root of 2. Don't leave it like this because you know you can simplify the square root of 100. The square root of 100 is 10. So you get 10 minus 4 square root of 2, and you cannot simplify the square root of 2 because the only perfect square that goes into 2 is 1. Also, you don't say 10 minus 4 is 6 because those are not like terms. This has a square root of 2 in it. This does not. All right, so that's it. That's all you can do. There's your answer. You cannot simplify this any further. All right, number 3. So let's suppose in number 3 we had the square root of 7 plus 3 times the square root of 7 minus 2. And so notice, if you go back to that review in the past, when you had x plus 5 times x plus 2, when you multiplied two binomials together, use the FOIL method. So x times x is x squared. The outer is 2x. The inner is 5x. And the last is positive 10. Combining like terms, you got x squared. Then you combine the first degree terms, so 2x and 5x is 7x. and then plus 10. The same thing here, two binomials. So I'm going to go ahead though and rewrite and just write the whole thing out so you can see what I'm doing. So you're going to say the square root of 7 times the square root of 7, just like this. Then the outer, you're going to remember a positive times a negative is a negative, so you're going to be subtracting. The square root of 7 times 2, square root of 7 times 2, and then positive times a positive is a positive, and then 3 square root of 7, 3 times square root of 7, and then a positive 3 times a negative 2 is a negative 6. All right, so first, outer, inner, last. Now, I can simplify this because I know the square root of 7 times the square root of 7, writing as 1 square root is the square root of 49, which many of you already knew it was 7. But I'm going to just go ahead and write square root of 49. Now, I'm going to rewrite this putting the square root in back. So I'm going to rewrite this as minus 2 square root of 7, and this already has the square root of 7 in the end, so plus 3 square root of 7, and then minus 6. All right, so let's simplify any further if we can and combine like terms. This is 7. Square root of 49 is 7, because 7 times 7 is 49. Those are like terms here, because both of those have a square root of 7. That's a negative 2, that's a positive 3. So that's going to be a positive 1 square root of 7. And then minus 6. I can combine 7 and negative 6 together, and so that's going to be 7 negative 6 is 1, so I get 1 plus the square root of 7. Now those are not like terms, so there's your answer. You cannot do anything else. All right, so let's get number 4. Number 4, let's suppose we had this for number 4. So we have 7 square root of 5 plus 2 times 2 square root of 5 minus 3. So it's very similar to number 3 right here, where you had to use a fall method, except notice that my first terms were square root of 7, square root of 7. The number in front of the square root was a 1 in both cases. Here, though, it's not. It's a 7, and that's a 2. But the work's the same. The approach you take is the same. So you're going to say first, outer, inner, last. So you're going to say 7 square root of 5 times 2 square root of 5. Okay, so that's your first. So first times first, and then the last. A positive times a negative is a negative, so be subtracting. And you're going to have 7 square root of 5 times 3. 7 square root of 5 times 3. Then the inner, you're going to have a positive times a positive is a positive. 2 times 2 square root of 5. And then the last, a positive 2 times a negative 3 is a negative 6. So first, outer, inner, last. Now let's simplify the first. 7 times 2 is 14. The square root of 5 times the square root of 5 is the square root of 25, or 5. Over here, over here I have 7 times 3 is 21, so I have minus 21 square root of 5, so that is this. 2 times 2 is 4, so it'll be 4 square root of 5, and then minus 6. Okay? But continue simplifying as much as you can before you combine like terms. So I have the square root of 25 is 5, so I have 14 times 5 right here. And let's just go ahead and combine these because we know we can combine those. So we're going to save some steps here, so some room actually. I have, see, those two are like terms because this is square root of 5 and this is square root of 5. So I have a negative 21 and a positive 4. So a negative 21 and a positive 4 will give you a negative, what's that, 17? So minus 17 square root of 5 and then minus 6. Now let's go ahead and rewrite this. 14 times 5 is going to be, what's that, 70? So I get 70 minus 17 square root of 5 minus 6. 70 minus 6 is 64. So you get 64 minus 17 square root of 5. And so that's your answer. You cannot combine those because this does not have a square root of 5 in it. So those are not like terms. So there's your answer. So that was number 4. In number 5, we saw something like this in our lessons this week, where we had a binomial squared. But remember what that means from previous courses and previous lessons and experiences that you've had. This right here, squared, means this times itself. So this means the square root of 5x plus 3 times the square root of 5x plus 3. And so what you did next, just like you did the previous problem, you used the FOIL method. So you said, well, that's going to be the square root of 5x times the square root of 5x, just like this. And then the outer, that's going to be a positive times a positive is a positive, so it'll be the square root of 5x times 3, just like this. Then the inner, a positive times a positive is a positive, 3 times the square root of 5x. And then the last, 3 times 3 is 9, so plus 9. So first, outer, inner, last. In the first, I know I can write this as 1 square root. 5x times 5x is 25x squared. Okay? And all I can do here is just put the radical in the end. So square root of 5x times 3. Don't say that's 15 because that's not a square root. Okay? If this was a square root of 3, then you could say 5 times 3 is 15. But that's not a square root right here. So I'm just going to put this in front. So it'll be plus 3 square root of 5x. And then it says 3 square root of 5x. What I want you to notice is this. You see that the outer and inner are exactly the same. The outer and the inner terms, that's because the binomials are the same. So if the binomials are the same, the outer and the inner will be exactly the same. And then plus 9. Now I want you to notice this right here. See, the square root of 25 is 5, and the square root of x squared is just x. So that, see how when I looked at this, the radicands were exactly the same? So the square root of 5x and the square root of 5x, that's just 5x. And you know it's true because the square root of 25 is 5, and the square root of x squared is x. These are like terms. So 3 square root of 5x and another 3 square root of 5x, 3 plus 3 is 6. So that's 6 square root of 5x, and then plus 9. Now notice I have 3 terms. None of those are alike. You see, these are not like terms right here because that's a 5x, but that's not 5x here. That's the square root of 5x. So those are not like terms. So that's all you can do is just rewrite it like this. There's your answer for that one. So that was number 5. When you look at number 6, we have the square root of 35k times the square root of 21k. So the square root of 35k times the square root of 21k. And so I'm going to write this as one radical. So use a calculator. 35 times 21. 35 times 21 is 735. And then k times k is k squared. Now splitting it apart now, I'm going to get the square root of 735 times the square root of k squared. So let's think about a perfect square that goes into 735. Now I want you to think about this. You see this right here, that 35, so remember what you did was you said 35 times 21, right? 35 times 21. Well, I know that 35 is 7 times 5. And I know that 21 is 7 times 3, right? So that means that 7 times 7 is 49. So I get 49 times 5 times 3. 49 times 5 times 3. So that, if you think about it, 49 times 5 times 3 is 735. So all I did was I thought about prime factorizations, and you learned that in probably 3 courses ago. So prime factorization. And so now I can think of this as the square root of 49 times 15. So it becomes the square root of 49 times the square root of 15. And this is easy because the square root of k squared, 2 is divisible by 2, so that's just k. Because k times k is k squared. And now let's think about a perfect, the square root of 49. So the square root of 49 is 7. So I get 7 square root of 15 times k. And I tend to put the radical on the end. So I'm going to put 7k square root of 15. 7k square root of 15. And so that's the answer there. All right, so that's number 6. Number 7, we have, let's see, we have the square root of 9 m to the 7th times n to the 11th times the square root of m times n to the 4th. All right, so again, just like we did this, let me pull it down a little. Just like when you have a product, we wrote it as one radical. We'll do the same thing here. So I have 9 times 5 is 45, so I get the square root of 45. Now I have m to the 7th. If you think about this, you have m to the 7th times m. Well, we know when you multiply like bases, you add exponents. So that's m to the 8th. So that's here. And then n to the 11th times n to the 4th will be n to the 15th. So we get this now. Okay, once we get to 1, now we're going to split it apart. So you get the square root of 45 times the square root of m to the 8th times the square root of n to the 15th. And now we're going to simplify each of those. So think of a perfect square that goes into 45, and so we know it's going to be that 9. So it'll be the square root of 9 times the square root of 5. This is a nice one. I can simplify this because 8 is greater than or equal to 2, and also because 8 is divisible by 2. So the square root of m to the 8th, 8 divided by 2 is 4. So it'll be m to the 4th power. M to the 4th times m to the 4th is m to the 8th. I can simplify this because 15 is greater than or equal to 2, but the problem is that 15 is not divisible by 2. So let's think about the largest whole number less than 15 that's divisible by 2. So so that's going to be an even number. So the largest even number that's divisible by 2 that's less than 15 is 14. So that's going to be the square root of n to the 14th times the square root of n. 14 plus 1 is 15. Now notice, so you see I have all these factors here. So let's simplify each one as much as I can. Square root of 9 is 3. I cannot simplify the square root of 5. The only perfect square that goes into 5 is 1. M to the 4th. The square root of n to the 14th. 14 divided by 2 is 7, so I get n to the 7th times the square root of n. And now remember, at some point you want to put these two together. So when you have the square root of 5 to the square root of n, since both of these have the same index, you can write it as 1. So I'm going to put everything else, all these other factors, in front. So it'll be 3 m to the 4th n to the 7th times the square root of 5n. And so that's number 7. Okay, let's look at number 8. So in number 8, we have this. In number 8, we have the cube root of 220 x y to the 4th squared. So again, don't let that problem throw you off. You're squaring this one factor, let's say this one term. So remember, that means the cube root of 20xy to the 4th times itself. That's what that means. And so since the indices are the same, I can write this as one radical now. So it's going to be the cube root. 20 times 20 is 400. X times x is x squared. Y to the 4th times y to the 4th. Think about that. Y to the 4th times y to the 4th. 4 plus 4 is 8. So that's y to the 8th. So that goes here. Okay? Now, let's go ahead and split them apart. We're at as separate radicals. So I get the cube root of 400 times the cube root of x squared times the cube root of y to the 8th. Okay? And so now let's think about 400. What's the largest perfect cube that goes into 400? So remember your perfect cubes. The smallest one is 1, because 1 cube is 1. The next one is 8. 2 to the 3rd power is 8. 3 to the 3rd power is 27, so the next one's 27. 4 to the 3rd power is 64. 5 cubed is 125, and so on. Okay? So there's an infinite number of those. Besides 1, can you think of another perfect cube here listed that will divide into 400 evenly? So use your calculator. Let's think about 408. So 400 divided by 8 gives us 50. And 8's the largest because the only perfect cube that goes into 50 is 1. So I cannot simplify the cube root of 50. So then I'm going to rewrite 400 as 8 times 50. So that's going to be the cube root of 8 times the cube root of 50. All right, let's think about this. I cannot simplify this because 2 is less than 3. So I'm going to all I can do is rewrite it. I can simplify this because 8 is greater than or equal to 3. But 8 is not divisible by 3. So let's think about the largest whole number, in this case odd, the largest odd number, less than 8, that's divisible by 3. So that's going to be, well, actually it's not necessarily odd, right? Because it could be even as well, because 6 is divisible by 3. So it'll be the cube root of x to the 6 times the cube root of x squared. So 6 plus 2 is 8. All right, so the largest whole number that's less than 8, that's divisible by 3. All right, now let's simplify each of those. The cube root of 8 is 2 times the cube root of 50. I cannot simplify the cube root of 50. I cannot simplify the cube root of x squared, so rewrite it. I can simplify this. That's 6 right here. 6 divided by 3 is 2, so that's x squared. Makes sense because x squared times x squared times x squared is x to the 6. And I cannot simplify the cube root of x squared. But you don't want to leave your answer like this because you know that, see that all these cube roots, you can write it as one cube root. So I'm going to get 2x squared times 1 cube root. And so it'll be 50 times x squared. I'm sorry, this is a y right here. Y. That's a y, excuse me. That's a y. So that's y squared right here. And that's a y right here. I'm sorry. See, that's y to the 8th. So that's 2y squared times, all right, so we get 50 x squared y squared. So that's the answer there. All right, so don't be a little bit careful. So we get 2y squared times the cube root of 50 x squared y squared. Okay, so that was number 8. Let's look at number 9. Okay, so number 9, we have the square root of 7 plus 2y times the square root of 7 minus 2y. And so just like we did previously, you have two binomials you're multiplying together. So let's use the FOL method. So I get first times first, the square root of 7 times the square root of 7. The outer, a positive times a negative is a negative. The square root of 7 times 2y, just like this. And then the inner, a positive times a positive is a positive. So you get this 2y times the square root of 7. And then the last, now be careful, that's 2y. And well, first of all, positive times a negative is a negative. 2 times 2 is 4. Y times y is y squared. So 2y times 2y is 4y squared. Okay? Now, I'm going to rewrite this. The square root of 7 to square root of 7 is square root of 49. And I'm going to put the square root of 7 in the back, on the end. So it'll be minus 2y square root of 7. This square root of 7 is already on the end. So plus 2y square root of 7. And then minus 4y squared. All right, now, this is 7 right here. So I get 7, square root of 49, 7. Now I want you to notice, see, this is y squared root of 7, and this is also y squared root of 7. So those are like terms. So a negative 2 and a positive 2, that's 0 right there. So all you get is 7 and then minus 4y squared. So there's your answer. And those are not like terms because that has a y squared in it, this does not. So you cannot combine those. All right, so that was number 9. And let's do one more. So this will be number 10, let's say. So let's say we had this for number 10. We had 3 square root of 7 plus the square root of 3 times the square root of 7 minus 4 square root of 3. So again, let's use the FOL method here. So I'm going to rewrite this as 3 square root of 7 times the square root of 7. So 3 square root of 7 times the square root of 7. So first, then the outer. A positive times the negatives will be subtracting. We have 3 square root of 7 times 4 square root of 3, right? This times this. So first, outer. Let's do the inner. So the inner, a positive times a positive is a positive. So I have the square root of 3 times the square root of 7. And then the last, a positive times a negative is a negative. So I'm running out of room here. So that's going to be the square root of 3 times 4 square root of 3. Okay? This times this. All right, so notice first, outer, inner, last. In terms of the first, remember we can put this as one square root now. So it would be 3, the square root of 7 times the square root of 7 to the square root of 49, which you know is 7. So what I want to do is just write it like this now, 3 times 7. So that is just 7 here. Okay? Over here, 3 times 4 is 12. So that's minus 12. The square root of 7 times the square root of 3, 7 times 3 is 21. So it'll be 12 square root of 21. All right, so I want you to see that this is this now. Here, the square root of 3 times the square root of 7, that's a positive square root of 21. And then here, this is 4 minus 4, and then square root of 3 times square root of 3 is square root of 9, which you know is 3. Okay? All right, so 7 times 3 is 21, so that's 21. These are like terms right here because they both have square root of 21s. This is a negative 12. This is a positive 1. A negative 12 and a positive 1 is a negative 11, square root of 21. And then over here, I want you to notice this is going to be, and let me write it out so you don't get confused. This is minus 4 times 3, square root of 9 is 3. So I get 21 minus 11 square root of 21. 4 times 3 is 12, minus 12. Now you see, now I have three terms, 1, 2, 3. You need to recognize which ones are alike. So I'm hoping you notice that the only ones you can combine are these two, because those are your constants. The only one that contains the square root of 21 is this one. The others do not, but those are constants. So I can add those. 21 and a negative 12 will give us a positive 9. So that's going to be 9 minus 11 square root of 21. And that's all you can do. You cannot combine those because this does not have a square root of 21 in it. Okay? So that is our review on topic 22 this week. So this is what we did this week in terms of topic 22. So that's going to be the end of this review.